All right, so today we are going to be talking about reflections. This is our first section in chapter 9. So for notes for this chapter, we're going to do them a little bit differently. So we're not going to have the slideshows, and the reason for that is transformations are more easily learned by doing them. I don't believe seeing words regarding transformations is going to do anyone very much good. I think it's really a hands-on thing, so we're going to just take more time to do examples and less time talking about what's going on with it. That being said, what a transformation is it's when you manipulate a shape, and you can do this a number of ways. So if I traced this triangle right here, a transformation, what we could do, we could slide it over here. We could, I don't know if I can turn with this. No, I cannot. So we can move it anywhere. We can slide it anywhere. What we could also do is we could flip it. Nope, not going to let me do it. That's fine. So we could flip it, or we could reflect it, in which it would look kind of like this. So the same thing, just a mirror image. We could rotate it, which would mean we would have a point that we rotated around, and then this triangle would just turn like it was a clock, and it might look something like that. And then we can also dilate the shape, so which makes it bigger or smaller. So in years past, when you've talked about transformations, you may have heard the terms slide, flip, and turn. So now what we're doing is we are going into, they're the same thing, but we're using the fancier math vocab. So now instead of a turn, or instead of a flip, we are going to have a reflection. Instead of a slide, we will have a translation. And instead of a turn, we will have a rotation. And I'm guessing slide, turn, and flip are the ones you've used before. We'll also talk about dilation later on. It'll be a future problem for us. But for today, what we're focusing on is just our reflections, or our flips. So what a reflection is essentially you have a shape like our lovely, lovely little triangle here in number 1. So we have this lovely little triangle, and what they want us to do is they want us to reflect it across line L. And what that's going to do is it's going to show the same shape, but it's going to be flipped, hence where your elementary school teachers would have gotten the term flip from. So how we can do this mathematically, which we're not in a coordinate grid, so it makes it a little bit more challenging to do so mathematically, but what we would actually do is each vertex of this triangle is a point, and what we would want to do is we would take a ruler and we would say, okay, this first point is right here. It is 68 from the line L that we're reflecting across, so we need to go 68 more, which can take us to 136. Oh no, I went too far. Okay, we're gonna try that again. So to 136. So that makes our line of reflection right in the middle. So it's going to be halfway through, and it's going to be a perpendicular angle. So what we're doing is we're drawing a perpendicular line from our original point, which let's just call that A, we'll call this B, and we'll call this one C. So we would draw a new point on this side, and we would call it A sub 1. And then we would go about and we would continue this process for all of these. So I would say, okay, C to the line is 306, so I need to go to 612, and we're not going to go past it this time. There we go, 612. And then we're going to draw our new point, and we're going to call that C sub 1. And we're going to do the same thing for point B, our final point. We're going perpendicular to that line, and so we're going to go all the way to the line, which is going to be 264, which would mean 528. 529 is close enough. And then we're going to draw in B sub 1. Now, what we would want to do is we would want to connect these new points to create the reflected image of that triangle. So that's how we can do this mathematically to make sure we get a perfect reflection. And with this triangle, maybe it wasn't completely necessary. Maybe we could have just done it by eyeballing it. But on some of them, it's going to get a little bit more confusing. So like, for example, this pentagon, maybe you have the vision and you can see it better. But me, to flip this or to rotate this across that line L is going to be a challenge. So what I would go ahead and do is I would just go ahead and use my ruler and I would make these lines. So we'll just call it 100 to there, so I need to go 100 past. Close enough, so that's going to be my new point for that line. I'm going to repeat the steps for the other 4-ish. Since that one point appears to be right on the line, I'm not going to worry about that one so much. So 218, so 436. So what I'm doing every time I choose one of these points, so let's just do this one, I'm saying, okay, so my distance to this line is 193. 2 times 193 is going to be 386. So what I'm doing is I'm making sure I have the same length of line on each side. So 386, which means I have 193 on this top side and on this bottom side. So I know they're equal to each other, which is how we get a true reflection. Now we have one more line. If I can get the ruler to cooperate. 62, so 124. Close enough. Okay. And like I said before, this point is kind of right on the line already, so we're just going to leave that as is. So I'm going to draw my point there, point here, point here, point here, and point here. And then I'm going to connect these lines to show my reflected pentagon. So that's my reflected pentagon. Is it artistically perfect? No. Does it need to be? No. It needs to be close enough. So essentially what a reflection is we are just flipping it over a line. Whatever that line is, doesn't really matter. It can be diagonal, straight up and down, straight left and right. Dealer's choice, really. So last one, I want to do one of these graphing ones just so you can see exactly what this looks like. So we'll just do number 3. It says graph each figure and its image under the given reflection. So what we're going to do first is we are going to want to graph the image. For this, I'm going to just go ahead and use black. So point A is -3, 3. So -3, 1, 2, 3 left, 1, 2, 3 up. That's point A. B, 1 right, 4 up. B, C, 4 right, 0 down. That's point C. And D is -3, comma, -3. So 3 left, 3 down. Okay. So that is going to be my original quadrilateral. And I'm going to do my best to draw straight lines here so it looks very pretty at the end. Because that's what's important, is having pretty drawings. Straight there. That's not half bad. And then they tell us we are going to be reflecting it across the line y equals x. So I'm going to draw that in with a ruler just so we have that exactly right, theoretically. So I'm going to draw that line in. I'll draw it in we'll do it in a faint yellow just so we can see it, but we don't need to see it all that. Oh, that didn't work. Nope. Wrong answer. Not faint yellow. Faint yellow, bad idea. Ruler, worse idea. All right, so we're going to try that again. Yellow with the pen. So we're reflecting across this line right here. So what that means is every single point we have to measure to the line of reflection and then do the same distance on the other side of the line of reflection. So when we do our reflected image, what I'm going to use is I'm going to use this red. So I'm going to start with point D because point D is on the line. So point D is on the line. That means D prime is also going to be right on that same point. So the next one we need to do is we need to do A. And now A, to get to this line of reflection, we go like this. And that should be perpendicular to that line of reflection. Now, since we went 3 diagonal spaces to the line of reflection, that means we need to go 3 diagonal spaces past the line of reflection. And then that's going to be point A prime. Now we're going to repeat the steps with B. We go 1.5 to the line, so we go 1/2 and 1 away from the line. So we're keeping that same spacing on both sides. Now C, we're going the opposite way, but we follow the same steps. So we go 1, 2 to the line of reflection and 1, 2 past the line of reflection. And that's going to be our C prime. So now we have our new shape. The last thing we need to do is connect these lines. Oh, that was a bad one. It was going so well up until that point. All right. So we have reflected quadrilateral ABCD across line X or Y equals X. In class, I will show you how to do this on GeoGebra.